Hi, so today we will be going through the coding interview questions that are asked for an embedded developer. So I will be taking you through the code and also will be explaining the concept behind it. Okay, so I have taken 5 questions as of now. So rest I will also take up in the upcoming videos. So first we need to do a byte swap. That is a common question. So I have copied here. So what's meant by a byte swap? So see here, the if LSB and MSB are here, so whenever there is a data transfer, see here the LSB has become MSB here. So what is the thing is that whenever there is a sender and receiver, so whether the data transfer via SPI or UART or I2C, so there is a byte format in general use. Okay, so what's a byte format? It will consist of two nibbles. So like if we consider as the first data as CC, so CC will be transferred and CC will be placed here, then it will be shifted. Okay, then 00 CC, then again this will be shifted, then 8 then sorry it will be 87, just a minute, it will be 87, then 87CC00, and lastly it will be FC0087CC. So it's actually shifting the data and appending the incoming data to it, right? So in that manner, whenever there is a communication, we use a shift register and we have a swapped byte of data. Okay, so this question will give an understanding how you understand shifting. So as I have already explained, so here we will be using the concept of shifting. Okay, right shift or left shift. So let me just clear the screen. Okay, now, yeah, so let's first understand how we are going to code it. So what we are having is CC8700FC. So what we need from here, first we need to take each byte out of it. Okay, then we need to shift the byte, like if we have FC first out, then we need to shift FC to this side so that we get FC00. Then we add the incoming byte, then again we shift FC00 to this side, so it will become FC0000 plus we add 87, so it will become FC0087. We shift the entire thing this side, so FC008700 plus CC, and then it will become FC0087CC. So like this. So what we are doing, so let's write the steps. First, extract byte to shift towards, we are shifting towards this side, so shift towards left. Third, add the new extracted byte. Okay, so this way we can do it. Fine, so let's open the editor. So I will be using an online editor so that it's easy for you guys to also code along with me. You can go to any online editor. I am using this one. So just let's say um, let's give it like, okay, so Whenever you are starting to do a code for an interview, try to make the problem like a function. Like every time you solve a problem using one function, so it gives a good impression. So if I say hash include, because I need to use you in 32, that's why std in dot h. Now I need you in 32, and we say swap bytes, and in it you have un32 data coming into it. Okay, so finally we'll take a un32 underscore t output, that will be 0x0, and then uint8 underscore t temp data, that will be 0x0. So why we need these two? Because we need one output, as we see, like, to store these values, and another is the temp to store this extracted byte. Okay, now so this operation of extracting, how many times this operation has to do? One, two, three, four times. Okay, so what we are going to need is a loop for int I equals to 0, I less than 4, I plus plus. Then, so first we need to do a shift. So output, whatever it is, okay, output will be equals to output shifted by 8 bytes, 8 bits, sorry. Then we need a temp. In the temp we need to store the value, that is data, the incoming data shifted by shifted by, every time we will be shifting the data by 8 into I. So why it is 8 into I? Because now look at this. So FC, we need the first. So what we are going to do here is, similarly, we are just going to AND it with FF. So when we do a AND with FF, everything's become 0. So we are doing a bitwise AND. So everything's become 0 and only we get FC. Similarly, if you want to extract next, then we need to shift this entire data towards the right. So CC8700, then again and FF with it. So we get 00, entire thing as 0. Now if you store this in a 8 bit of data, then only FC will be stored, rest will be eliminated. Okay, so that's what we are doing. So here every time we are shifting 8 bits, and we are, sorry, it should be right shift in this case, and then we will be ANDing it with 0 cross FF. Okay, then the last thing is output will be plus equals temp. So whatever is the temp data, we are adding to the output, shifting the output, adding to the output likewise, and then finally we return output. Okay, so let's try this code. So we will have AUint 32 input equals to, let me copy the same exact thing. Comma, and we define an output equals to 0x0. Okay, so just let us, okay, no need to do this, directly define this. Swap input. Okay, and in the hello world we will just try to say what is input equals to 0x, sorry, 0x percentage x. So percentage x will give you the in the hexadecimal format. Okay, is the input, and output equals to 0x percentage x. So it will be input comma output. So let's run this. Okay, see here. Yeah, so this is what we required. So it got so. So I hope you understand this. So now let's move on to the next one in our list, that is set reset logic for a 32-bit variable. So this is another very important coding challenge that are given, because in here we always need to set or reset a bit in a control word, or in a control word, right? So that's why, so in this logic it's basically like you have a set of bits. Let's say you have a certain set of bits, like 1 0 0 1 1 0 1 1. So 1 2 3 4 1 2 3 4. Okay, so this may be the control word, and I would say in this control word set the fourth, set the, not fourth, let's say set the third bit. So it should become 1 0 0 1 1 1 0 1. So only this bit will be set. Similarly, we can say in the control word reset the fourth bit. So we should have 0 0 1 0 1 0 1, right? So fourth bit got resetted. So this should be having one function which will take whatever control word we give and the bit number we give, which we want to set it or reset it, and then this function will return the value after setting that particular bit, right? So basically what we have to do here, so let's just first understand how we are going to achieve this. Okay, so it's easy, like 1 0 0 1 1 0 0 1. Now, whichever bit you want to set, put 1 in that position and do an OR operation with it. So it will become 1 1 1 0, right? Whichever position you want to set. So how we put a 1 in this position? It's very simple. Keep 1, shift towards the right by the number of bits you need, here 3, so it will become 10003, right? So likewise, sorry, in this case we will be putting 2, so it will shift towards 2 bits. Likewise, so so we need to just so for and what we will do, so like this is for OR operation. For and again, you see, we have the similar if we put 00111101. Now I am saying for we need to reset it. Okay, so reset bit 0123, third bit. If I want to reset the third bit, you see what we need to do here. So resetting the third bit means we need to put a 0 and do a AND operation. But if we do an AND operation with just 0 at this position, everything becomes AND. So we need 1 1 1 1 1 1. If we do an AND operation now, so now it will become 0 1 0 0 1, right? So how to get this to do an ANDing? So it's very easy. You put 1, okay? You do the same operation. Shift it to 1 2 3 4, third position. So you get 1 0 0 0. Now you take a complement of it. So you get 0 1 1 1. And if it is a, let's say 16 bits, so all bits before it will become like this. Oh, sorry, before it become will be like this. So this is 4, this is 4, yeah, 16. Okay, sorry, 8 bits. So you get the point, right? So there are two operations. One is shifting and taking a complement when we do a reset, and then just shifting and doing an OR to get a set. So just let me put it in a clear manner. For set, shift 1 to left and OR operation. Simple. Reset, shift 1 to left, then take complement and operation. Okay, so this is what we are going to do. We'll open the code plane. I will clear this one. Okay, then similarly we'll write uint 32 underscore t set bit. So you take uint 32 underscore t data comma uint 8 underscore t bit number. So this bit number will give you which bit to set. User will have to input. So now what we need to do is we need to set it. So simple. So for setting, shift 1 to left and OR operation. Simple. So we take data. We say data. We say data equals to data or operation with data. We have 1 shifted to bit number. Okay, and we return data. That's it, right? So let's test it. So let's just keep it in this way, and here we just put swap input comma bit number let's say 2 we want to set, and for simplicity we will give one number as 7. So if we write 7, 7 is 111. So okay, so we can say we need to set the 0 1 2 3 third bit. Okay, third bit we want to set. So just run the code. See here F is coming, right? The third bit is set, so it will become 1111. Okay, similarly let's write the reset logic. Reset bit. So you check what we have written here. Shift 1 to left, then take a complement and operation. So first thing is we need to do an and operation. Then we just need to take a complement and we keep it in a bracket, and that's it. So in this case, let's say we put a reset. So reset bit number. So already we have everything, we put 2. So after reset it will become 001, right? So this is 3. So let's run it. Yeah, 3 we are getting. So this is how we do a reset and set operations. Okay, now let's move to another next question. So next question is, we need to write a macro to find the largest of 3 number. Okay, so what do you mean by largest of 3 numbers? It's easy, right? Like 5, 4, 8. So largest of 3 is 8. But we need to implement a macro to solve it. Okay, so let's go. And also in this question one trick will be played, like you cannot use if else. Now this is a complicated one. You cannot use if else, but still we are, anyhow we will be going to use just comparators. So let's directly jump into coding. There is no concept in it. So let me just remove all this. Let's say we just write a macro as define max. So every time when you write a macro, you should keep the sense that it should always be in a capital letter. It's like a coding standard. So we give x comma y comma z. These are the 3 numbers we are going to give it, and this macro should return us the max out of it. So first thing what we need to compare, whether x is greater than y. So if x is greater than y, then we also need to check if x is greater than z. So if x is greater than z, then we return x. Else we need to check if z, oh sorry, first thing we check x is greater than y. Yes, x is greater than, if no, x is greater than y. Yes, x is greater than y. X is greater than z. Yes, that means x is the highest. We give x. Now if x is not greater than y, then of course z is greater, because already x is greater than y and z is greater than x. That means z is already greater than y. Now then another thing comes in, if so this is solved from this point. this is this is the first part. Now comes the second part is if x is if y is greater, then what we need to check. If y is greater than z, then pass. If y is greater than z, then give z. If y is not greater than z but y is greater than x, then you give z, right? So this bracket completes this is the entire bracket, this bracket completes this, yeah. Now we give two numbers, int no need to give. So let's just move everything and write max equals to percentage d, and you give max 8 comma 11 comma 5. Let's run it. See, here 11 is given, so if I give 15, then we should get 15. Yes, 15. So this is how you do without using any if else. We just use a statement and we do this. Okay, so next again, this is an interesting one. Swap two numbers without using any extra variables. Okay, so this is very common question just to know how good are you in arithmetics. So it is like if you have, let's say, a equals to 4 and b equals to 6. So the answer should be b equals to 4 and a equals to 6 without using any extra variable. No extra variable. You cannot do c equals to a, then a equals to b and b equals to c. This is not allowed. So how you do it? Very simple. So just keep in mind this function, simple. You don't need to write a code also. So we keep a equals to a plus b. Now b equals to a minus b, and sorry, a equals to a here. So from it will be b equals to a minus b and a equals to a minus b. Bit confusing, right? So what's happening actually? So 4 plus this is 10. Then from 10 we are subtracting b. B is 4 here. So 4, that's give us 6. So now b it is equals to 6. Now then we have again 10 minus 6, that is equals to 4, that is equals to 8. So fine, right? So if we do it, so if you want me to solve, okay, fine, I will do it. Okay, I will solve it using pointers. Okay, so let's do it via pointers. Let's say void swap int star a comma int star b. Okay, so we want to swap it. So swapping means we need to do a, okay, a and b. So a star equals to a star plus b star. Now b star equals to a star minus b star, and a star equals to a star minus B star. Okay, so you understood, right? Star, this means the value. So here we can just say int a equals to 8 comma b equals to 77, and then a b a comma b, and here we just call swap percent a comma percent b. So we just run it. Mm, okay, okay. So I think I put it in a wrong way. Yeah, see, now A has become 77 and B has become 8. So let's go to the next question. So next question is bit field. So this is an important question, like what is bit field? It is basically understanding, like suppose you want to have one status. Let's say you create a struct and you say status of LEDs. Okay, and you have say 8 LEDs. So int LD, int LD1, like that. So it will be 2, 3, 4, 5, 6, 7, 8. So for 8 LEDs, you will be using a total of 8 into 4 bytes. So in total, this the size will become 4 into 8, that's equals to 32 bytes. Okay, let's see the size. Okay, let's just declare it. Struct status of LED, status 1, size of percentage D, size of status. Okay, let's run it. See. Okay, sorry. Here. No. So size is 32. So now you understand, right? So an LED can only be on or off. So off, that means 0 or 1. To store 0 or 1, how much bytes we need, or we can say how much 1 bit is enough, right? So why you need to waste 32 bytes of data? that is like 32 into 8 bits will be utilized, right? So how to solve this? So this here it comes the concept of bit field. So we say for this we use 1. Similarly, we will do for all, we say we use only 1 bit to store the status. Now you run it. See, only the size is 4 bytes. Okay, so this has drastically reduced your size, right? So this is how the bit field concepts comes into the picture, and it helps in reducing the memory size. So it depends how much mm, is actual requirement of memory, and you can do it, right? So this is all about today's lecture video, and thank you.